Yeah, good evening, children.
Good evening, ma'am.
Good evening.
Good evening.
Good evening, children. Yeah, actually, I finished my class at 9:15 and one parent had come to meet. She was unaware of the class which I have today. No, I normally don't have a class after the last batch at 9:15. So the parent dropped in and, like I was obligated to talk to them. I'm sorry about the delay. Yeah. So here, so this is NCRT, children. First exercise in NCRT, the last question. In right triangle ABC, right angle at C. So see here, the figure is below here. In a right triangle ABC, right angle at C, right angle at C, M is the midpoint of the hypotenuse AB. M is the midpoint of the hypotenuse AB. That means what? AM is equal to BM. C is joined to M and produced to a point D. C is joined to M and produced to a point D such that DM is equal to CM. DM is equal to CM. So we have two things here. AM is equal to BM. See it? It's given that M is the midpoint of AB, which means AM is equal to BM. It's also given that it's directly given that DM is equal to CM. DM is equal to CM, which means M is the midpoint of both AB and the CD. M is the midpoint of both AB and CD. Okay, so we have two equalities. AM is equal to BM on the hypotenuse AB. And then on this line segment CD, we have CM is equal to DM. Okay, so we have this information. Now point D is joined to B. D is joined to B. Point B is joined to B. Show that, this is the first one, triangle AMC is congruent to triangle BMD. These two triangles are congruent to each other. So let me call this triangle 1 and triangle 2. So in the first triangle, angle 1 is equal to angle 2 of the second triangle because vertically opposite angles are equal. Angle 1 of the first triangle is equal to angle 2 of the second triangle. Vertically opposite angles are equal. DM of the first triangle. See, DM is a side of the first triangle. It is equal to CM of the second triangle. DM is a side of the first triangle. CM is a side of the second triangle. DM is equal to CM. It's given to us. Then BM of the first triangle. BM of the first triangle is equal to AM of the second triangle. BM is equal to AM. That because it's given, no? M is the midpoint of AB. M is the midpoint of AB. So which means BM is equal to AM. BM is the side of the first triangle and it's equal to AM of the second triangle. And you can see that we have mentioned about the sides DM and BM of the first triangle. We have mentioned about the sides DM and BM of the first triangle. These two sides include angle 1. And the second triangle, we have mentioned about AM and CM. AM and CM. And these two sides include angle 2. And angle 1 is equal to angle 2. Vertically opposite angles are equal. So this makes SAS, two sides and the included angle. SAS congruence criterion, the two triangles are congruent to each other. Correct? Yes or no, children? Understand?
Yes, ma'am.
Yeah. So that's what you see here. That's what you see here. I'll share the slides with you later. You can copy down by the next class tomorrow. So what I just told you is what is here, children. The two triangles are congruent by SAS congruence criteria. Next, we'll have to prove that angle DBC is a right angle. Angle DBC, this angle is a right angle. Because in the question, we are only given that angle C is 90 degrees. In the question, we are given that angle C is 90. We have to prove that angle DBC is 90. This angle is 90. Okay. Now, since the two triangles are congruent to each other, I'll use this figure, children. Let me use this figure and tell you. So here, this triangle is congruent to this triangle. So angle 6 will be equal to angle 5 CPCT. Angle 6 is equal to angle 5 CPCT. It's not given. 6 is equal to 5 is not given. But we have proved that the triangles are congruent to each other. So because they are congruent, their corresponding angles are equal. So angle 6 of this triangle will be equal to angle 5 of this triangle. Now we'll be like, how do you know 6 is equal to 5? From the way we name the triangle. See, DMB, triangle DMB is congruent to triangle CMA. You know, you can name the triangles in different ways. This is one of the orders. DMB, if you say DMB, it'll be CMA. So you can see that D of the first triangle is equal to C of the second triangle. We have learned how to name the triangles in the correct order. So you should use that and name the triangles in the correct order. Then you will see that the vertex D of the first triangle coincides with vertex C of the second triangle. Okay, so CPCT will have angle 6 equal to angle 5. But what kind of angles are 6 and 5? They're alternate interior angles. See here, there is a line, transversal, a line. We have angle 6 here, we have angle 5 here. This line is DB and this one is AC. Now angle 6 is equal to angle 5, CPCT. But angle 6 and angle 5, they are alternate angles. By the position, they are alternate angles. If angles are in such positions, they are alternate angles. They are alternate angles made by the transversal DC with the lines DB and AC. And the alternate angles are equal. How do we know they're equal? Because the triangles are congruent. The corresponding angles are equal. So since the alternate angles are equal, the lines must be parallel to one another. That means DB is parallel to AC. DB parallel to AC. So we proved that DB is parallel to AC. And this is 90 degrees. So see here. DB, AC. DB is parallel to AC. And this is 90 degrees. Now these two angles are co-interior angles. Co-interior angles are supplementary. So if this is 90, this is also 90. Therefore, angle DBC is equal to 90 degrees. DBC is equal to 90 degrees. You can also make use of this angle and this angle. You can also make use of these two angles. Angle 4 is equal to angle 3. Why? Because these two triangles are congruent to each other. So their corresponding angles are equal. Angle 4 of this triangle will be equal to angle 3 of this triangle. So angle 4 is equal to angle 3 CPCT. CPCT. Now let's see how they are located 4 and 3. 4 and 3. There's angle 4 here. There's angle 3 here. Angle 4, angle 3. D, B, A, C. Now angle 3 and angle 4, by the position, by the way they are positioned, they are alternate interior angles. And they are equal because the triangles are congruent. So CPCT corresponding angles are equal in the two congruent triangles. So angle 3 is equal to angle 4. But they're alternate interior angles made by the transversal AB with the lines DB and AC. So since the alternate angles are equal, the lines DB and AC must be parallel to each other. So like this also you can prove that the lines are parallel. You can make use of angle 6 and 5. 6 is equal to 5 CPCT, but they form a pair of alternate interior angles. So the lines are parallel. Or you can make use of 4 and 3. So you need to prove that the lines are parallel. Okay, so prove that DB is parallel to AC. And after that, look at the figure like this. This angle is 90 degrees as given in the question. Parallel lines, transversal. BC is the transversal. Co-interior angles are supplementary. So this is 90, this is also 90. So angle DBC is a right angle. We proved that. Next, we'll have to prove that triangle DBC is congruent to triangle ACB. It's congruent to triangle ACB. DBC, ACB. See here? DBC, ACB. Both are right triangles. Both are right triangles. We just proved that this is 90 degrees. Okay. Now, we'll have to show that these two triangles are congruent to each other. All right. Now, going back to the first one, we have proved that this triangle is congruent to this triangle. So from CPCT, you will have DB equal to AC. That is DB of this triangle. See here? We have proved that this triangle is congruent to this triangle. So DB of this triangle will be equal to AC of this triangle, CPCT. Once you prove two triangles are congruent, their corresponding angles and corresponding sides will be equal. So we have proved, see here, look at this. AC is equal to BD, CPCT. AC, you can see here, AC is equal to BD, CPCT. So AC is equal to BD, CPCT. All right. So in these two triangles, DB is equal to AC is not given. We have proved that these two triangles are congruent. So CPCT, we have this result. DB is equal to AC. DB, see here, I'm showing you again. DB is equal to AC, CPCT. Yeah. And then in this triangle, this angle is 90 degrees. In the other triangle, again, we have 90 degrees here. And then BC is a side common to both the triangles. Both the triangles have a common side BC. So DB is equal to AC. BC is the common side, 90 degrees. So this makes side, angle, side. So two sides included angle. See here, we have mentioned that this side is equal to this side. This is the common side. This is the common side. So these two sides contain this angle and these two sides contain this angle. So by SAS congruency, the two triangles are congruent to each other. So DBC congruent to ACB, SAS criterion. SAS criterion. DBC congruent to ACB, SAS criterion. So you can see here, DC is equal to AB. Children, see, this one has to be named in a particular order. And we have discussed that. You cannot write, you cannot name it in any way. Once the triangles are congruent, once you show that the triangles are congruent, naming the triangles in the correct order is very important. Only then you will get the corresponding parts correctly. So like DC is equal to AB. DC is equal to AB. So DC is equal to AB. DC is equal to AB. Let me clear the screen and show you again. DBC ACB. All right. So you can see here DC is equal to AB. DC is equal to AB. Okay. Now we have to prove that in the fourth one, we'll have to prove that CM is equal to half of AB. So let's start with, DC is equal to AB. DC is equal to AB. Let's start like this. To prove the fourth result, from the third one, we'll take a CPCT information. That is DC equal to AB, because we have AB in the fourth result. No, we have AB here. We have AB here. So AB is equal to what? AB is equal to DC. Let's write that. And in the fourth one, what you see is half of AB. So DC is equal to AB. Half DC is equal to half AB. Halves of equals are also equal. Halves of equals are also equal. DC is equal to AB, CPCT. So half of DC will be equal to half of AB. Now what is half of DC? Half of DC, see, this is DC. This is DC. And it is given that DM is equal to MC is given in the question. DM is equal to MC is given to us in the question. So half of DC, you can write DM or CM. Half of DC, because it's given that DM is equal to MC. That means M is the midpoint of DC. So half of DC can be DM or CM. Anything. But here what is there in the result? CM. So instead of half DC, you write CM. Instead of half DC, you write CM. So CM is equal to half of AB. That's what we have to prove. I'll do this again. Once you prove the third one, take a CPCT information from the third one. Look at the fourth result. It has AB here. So AB is equal to what? DC. Write that. DC is equal to AB. Write that information. CPCT. Now, since we have half AB, we'll also take halves of these equals. So half of DC is equal to half of AB. Now, half AB will have it as it is, because you can see that in the final result, half AB. Now, what is half of DC? Half of DC can be written as DM or CM, because DM is equal to CM. Anything you can write. So half of DC you can write DM. Then the result is DM is equal to half AB. Or you can write for half of DC, you can write CM. CM is equal to half of AB. Yeah, that's what we had to prove. So CM is equal to half AB. Okay. So this is the first one. Yeah, I think since all of you are online, you can take a screenshot, children. Yeah, please take a screenshot.
Mom.
Okay, very good. Okay. AB is a line segment. Okay, AB is a line segment. Yeah, 1 second. Now here, if the figure is not given, if the diagram is not given, you need to know how to draw the diagram. So let's do that. In right triangle ABC. So you can even draw it like this. In right triangle ABC, right angle at C. So ABC is a right angle at C. In right triangle ABC, right angle at C, M is the midpoint of the hypotenuse AB. M is the midpoint of the hypotenuse AB. See, sometimes the diagram, the figure is not given, children. In that case, you'll have to read the question and draw the diagram. So we'll do that. In right triangle ABC, so you can see here, in right triangle ABC, right angle at C, M is the midpoint of the hypotenuse AB. Okay. C is joined to M. C is joined to M. Okay. And produced to a point D. And produced to a point D such that DM is equal to CM. So such that, so you produce it to a point D. That means if supposing CM is 3 centimeters, you produce it so that MD is also 3 centimeters. CM is joined, CM is joined, C is joined to M. Now, supposing CM is 3 centimeters. Now CM is joined and it's produced to a point D. It's produced to a point D such that CM is equal to MD or CM is equal to DM. That means if CM is 3 centimeters, you produce it to a point D such that DM is also 3 centimeters. Okay. Then, so C is joined to M and produced to point D such that CM is equal to DM. Point D is joined to P. D is joined, sorry, B. D is joined to B. So this is the figure. I hope all of you understood. Should I repeat, children? All of you got that?
Yes, ma'am.
Okay. See, here it's given, here it's marked like that. That's fine. The figure given here is like this. Triangle ABC is like this. That's fine. This is also right. If the figure is not given, you can even draw it like this. Okay. AB is a line segment. Okay, we can see the figure here. And P is its midpoint. Okay, so P is the midpoint of AB. D and E are points on the same side of AB. D and E are points on the same side of AB such that angle BAD, this angle BAD is equal to ABE, this angle. These two angles are equal. Angle 1 is equal to angle 2. And EPA, this one, this angle 3 is equal to DPB, this one. So angle 1 is equal to angle 2, angle 3 is equal to angle 4. Okay. Show that triangle DAP, yeah, this DAP is congruent to EBP. EBP. Okay. EBP is a triangle we see there. EPB. I'll let you do. Now, when you look at the angle marked here, see this angle 3. This angle 3, it's a part of the triangle DAP. Angle 3, see here, if you include this portion, that is angle DPA. To angle 3, if you add this portion, to this angle 3, if you add this portion, then that will be angle DPA. DPA. See here, DPA. This angle DPA is 3, and let me call this angle 5. This one 5, okay? So this angle DPA is 3 and 5 together. See the figure given in the question and the two triangles which I have drawn. In this triangle DAP, look at this angle. This angle is angle DPA. Now look at the figure. Look at the figure. DPA. DPA is angle 3 and 5 together. Angle 3 and 5 together is angle DPA. So that's what I've marked here. And in the same way, this angle, how do you name this angle, or how do you read this angle? EPB. EPB. All right, EPB. Now look at the figure given in the question. EPB is 4 and 5 together. EPB. Here, EPB is 4 and 5 together. So this angle here is 5 and 4 together. All right. And this is angle 1. This is angle 1. And this is angle 2. Okay, I think now we are ready. And we also know that P is the midpoint. P is the midpoint of AB. P is the midpoint of AB. That means AP is equal to BP. AP is equal to BP. It's given in the question that P is the midpoint of AB. That means AP is equal to BP. So see here, this AP is equal to BP. Is equal to BP. So in triangle DPA and triangle EPB, in the two triangles, angle 1 of the first triangle, see the triangle DPA, angle 1 of the first triangle is equal to angle 2 of the second triangle. That's given. It's given. Angle 1 is equal to angle 2. Then AP of the first triangle is equal to BP of the second triangle. Because P is the midpoint of AB. AP is equal to BP. Then in the question, it's only given that angle 3 is equal to angle 4. In the question, only this is given. Angle 3 is equal to angle 4. So we know that when equals are added to equals, the wholes are also equal. When equals are added to equals, the wholes are also equal. So we'll add angle 5 to both the sides. We will add angle 5 to both the sides. Okay, so angle 3 is equal to angle 4 is given to us. We'll add angle 5 to both the sides. Angle 3 plus angle 5 is equal to angle 4 plus angle 5. Now what is 3 plus 5? It's angle DPA. Angle 3 plus angle 5 is angle DPA. Is equal to, what is 4 plus 5? EPB or BPE, whatever, is equal to EPB. So now this makes two angles and the included side. Two angles and the included side. Because in the first triangle, we have mentioned about the side AP, and the angles at A and P. And the angles at A and P. See here, we have mentioned about AP. In the proof, we have mentioned about AP. And we have also mentioned about angle A and angle P. So two angles in the included side. The same thing in the next figure. We have mentioned about BP. In the proof, we have mentioned about BP. And the angles on BP are this angle and angle 2. So by ASA, two angles and the included side, congruence rule, the two triangles are congruent to each other. Now, the order in which, see, the order is given in the question. It's given in the question. Supposing you write, you don't notice that you write it by yourself. If you say APD, is congruent to, when you say APD, A goes with B here because angle 1 is equal to angle 2. So A goes with B. And P is the same angle, meaning P, vertex P here in the first triangle and vertex P here in the second triangle. Angle 3 plus angle 5 in the first triangle is equal to angle 4 plus 5 in the second triangle. So the vertices P coincide. So it will be P here also. And D goes with E. So APD, BPE. But what is given in the question? In the question it is DAP. So see DAP. If you say DAP, then it will be EBP. If you say DAP, then it will be EBP. That's what is given in the question. DAP, EBP. So the order in which you name the triangle is very, very important. The next thing you'll have to prove is AD is equal to BE. AD is equal to BE. So you can see here, AD is equal to BE. CPCT. The triangles are congruent. So the triangles are congruent. Their corresponding angles and sides are equal. So AD is equal to BE, CPCT. I'll just wait for 3 minutes. You can go through the proof. Yeah, take a picture, children. Taken.
Took screenshot, ma'am.
Yeah. Okay. In this one, in the figure, AC is equal to AE. You can see it's also marked. AC is equal to AE. AC, where is AC? Yeah, AC, this one. AC is equal to AE. You can see the double lines. And AB is equal to AD. AB is equal to AD. Okay. And then BAD, this angle is equal to EAC, this angle. Okay, so there's a little gap here. Now show that BC is equal to DE. Show that BC is equal to DE. So to show the two sides that equal, children, you will have to take up two triangles. One triangle which has BC as a side and another triangle that has DE as a side. Take up one triangle which has BC as its side, another triangle which has DE as a side. Show that these two triangles are congruent to each other. So once they're congruent, CPCT, BC is equal to DE. So you must take up a triangle that has BC as a side and another triangle that has DE as a side. And try to include, the equalities, the information regarding the equalities given. The triangles you choose, they must also have the information which is given to you because you need information to show that the triangles are congruent. So make sure that you use the triangles, meaning you select triangles so that you have this information in them. Now BC, so see here, this is BC. BC, so you have to take up the triangle ABC. And we are right because in ABC, see here we have a single line marked and a double line marked. Okay, so that means that information which is given to us. So when you take up the triangle ABC, one of the triangles ABC, it has BC as a side, okay? And that information, you can see a single line here and a double line here. So let ABC be one triangle. Then for the other triangle, DE. So DE is here. So DE means you should take up the triangle ADE. ADE. In ADE also you can see on AD we have the single line here and on AE we have the double line here. Okay, so take up these two triangles. The triangles are triangle ABC because it has BC in it. And you should take up the triangle ADE because it has DE in it. We'll have to show that BC is equal to DE. So you should take two triangles which have these sides. ABC has a side BC, ADE has a side DE. Okay. So let me draw ABC. ADE. ADE. So let me mark the equal sides given. AB is equal to AD. So see here, AB is equal to AD. Then AC is equal to AE. AC is equal to AE. And angle BAD. You can see that in these two triangles, we don't have BAD, angle BAD. See, BAD is equal to EAC. but we are unable to mark this information in these two triangles. It's given that BAD is equal to EAC, but BAD, EAC, they are not angles in these two triangles. We are unable to mark that information. First is about the selection of the triangles, children. So selection of the triangles depends on what you have to prove. You'll have to show that BC is equal to DE. So we have taken triangle ABC because it has BC in it. And then we have taken triangle ADE because it has DE in it. DE in it. So now we have selected the triangles. After selecting the triangles, mark out the information given. It's given that AB is equal to AD. So that's single line. Then AC is equal to AE, double lines. Then there's another thing given, BADEAC, but that we're not finding in these two triangles. So let's go back to the main figure. Okay, BAD, this angle is equal to EAC, this angle. But if you mark this, so supposing we mark this angle 1, 2, and this one as 3. Now let's see what is 1 plus 3. 1 plus 3. Name angle 1 plus 3, children. Name the angle 1 plus 3. How do you name the angle 1 plus 3? Angle?
Angle BAC.
BAC. BAC. And how do you name angle 2 plus 3?
Angle DAE.
DAE. Very good. DAE. Now just check if BAC and DAE are angles of these two triangles. See, first two angles are given to be equal. Two angles are given to be equal, but we don't find those angles in these two triangles. BAD, if you see BAD, D is not a vertex at all here. B in BAC, how can you mark BAD? So not possible. In this triangle, where is EAC? We have EAD, but where is EAC? Not there. So the angles which are equal cannot be marked in these two figures. So when you compare this triangle ABC with the whole figure given here, ABC, you can see that this angle see in ABC triangle, this angle is 1 and 3 together. And in the triangle DAE, this angle is 2 and 3 together. So in the triangle ABC, we have this angle, this full angle, which is this angle 1 and 3 together. And in the other triangle ADE, see it, ADE. In the other triangle ADE, where this one is this angle, this vertical angle here. Here in triangle ADE. Yeah. You can see this angle is 3 and 2 together. 2 and 3 together. But we are given that angle 1 is equal to angle 2. We are only given that angle 1 is equal to angle 2. That is, we are given that this angle is equal to this angle. But 1 and 2, no, we can't see them in these two triangles at all. In these two triangles, when you try to mark BAD and EAC, you don't find the angles. Because BAD and EAC are not complete angles in the two triangles. You must add something to them. Then it becomes a complete angle in the two triangles. And what you should add is angle 3. Angle 1 plus angle 3 is angle BAC. Is angle BAC. Is this angle. You can see the main figure. In the main figure, see angle 1 and 3 together. 1 and 3 together. It's BAC. So here it is. And 2 and 3 together. 2 and 3 together in triangle DAE. DAE, 2 and 3 together is this whole angle. So what's the rule, children? What is the rule? What's the congruence rule?
Miss, yes, miss.
Yes, correct. Two sides and the included angle. Two sides and the included angle. Now, why we add 3 to both the sides? Why we add 3 is because the given angles BAD and EAC. See, the given angle BAD, you try to mark BAD here. There is no angle BAD at all in this triangle. Then try to mark EAC in the second triangle. Try to mark EAC. EAC, it's not there. So go back to the main figure. That's what I said. Go back to the main figure. What is given is BAD. That is this angle. BAD is this angle. 1 is equal to EAC. EAC. Okay. So these two angles, the equal is given. Now in the middle, there's an angle. We call it 3. 1 and 3 together is this angle BAC. 1 and 3 together is this angle BAC. And 2 and 3 together. 2 and 3 together is the angle DAE. DAE. So as Hari Pranav said, SAS rule, the two triangles are congruent to each other. So CPCT, you will get the result BC is equal to DE. Yeah. Go through and take a screenshot. So you can see I've marked here in the first triangle, angle 1 is not a full angle. 1 and 3 together is a full angle. And in the second triangle, 2 and 3 together is a full angle. That's why when we have angle 1 is equal to angle 2, we add angle 3 to both the sides. So you'll get 1 plus 3, which is this full angle, is equal to 2 plus 3, which is this full angle. Yeah, take a picture, children. Done, children?
Yes, ma'am.
Okay. Okay. Yeah, we'll do this one and wind up the session for today. So line L is the bisector of angle A. So angle A, L is the bisector. L is the bisector of angle A. This is angle A. This full thing is angle A. L bisects it. That means if this full angle is 80 degrees, L bisects it, makes it 40-40. The angle is bisected, meaning divided into two equal parts. Okay. So initially we have this angle A. See here, we have angle A. Arm, this is one arm. Okay, it's not marked, so let me not do it. Okay, so we have angle A like this. Then there is this line L going through the vertex and bisecting angle A. So this angle 1 is equal to angle 2 because the angle is bisected. BP and BQ are perpendiculars from B to the arms of angle A. So we know that this is one arm of angle A. This is the other arm of angle A. Now from this point B, what is B is actually a point. B is any point on L. I didn't read that, I think. I didn't read this. B is any point on L. B is any point on L. I think I missed to read that. Children, let me come again. See here, we have angle A, children. We have angle A. These are the arms. These are the arms of angle A. There's a line L. There's a line L that bisects angle A, which means this part is equal to this part. Angle 1 is equal to angle 2. Okay, so that's what is from here to here. Line L is the bisector of angle A. And B is any point on L. B is any point on L. Okay, so B is any point on L. BP and BQ are perpendiculars from B to the arms of angle A. So you know the arms of angle A. BP and BQ are perpendiculars from B. So BP perpendicular, BQ perpendicular. BP and BQ are perpendiculars from B to the arms of angle A. So BP and BQ. So it's not very specific where is P and Q, but the figure is given, so I'm taking it here. Now, supposing the figure is not given and you have to draw it by yourself, then it will be very specific. They would have named the arms, like they would have given points here, like say M and N. Okay, so BP is a perpendicular on the arm AN and BQ is a perpendicular on the arm AM. So if the figure is not given, and if the question is given and you have to make the figure, you have to draw the figure, then the arms will be named because you don't know on which arm BP and BQ are landing. So then the arms will be named like this. So I've named it was here arm AN, arm AM. AM and AN are the arms. So in the question, it will be clear that BP is a perpendicular from B on the arm AN and BQ is a perpendicular on the arm AM. So it will be mentioned like that. Okay, so here I'll just remove this. Yeah. Show that triangle APB, this one, this triangle is congruent to AQB, this triangle. So show that these two triangles are congruent to each other. So we have all the information there. Angle 1, let me call this one as the first triangle. This is the first triangle. This is the second triangle. Okay. So this is what we'll have to show that these two triangles are congruent to each other. So angle 1 of the first triangle is equal to angle 2 of the second triangle given, because L bisects angle A. Okay, and then AB is a side common to both the triangles. AB is a side common to both the triangles. AB is a side of triangle 1. AB is also a side of triangle 2. So AB is a common side. Then angle 3. In triangle 1, angle 3 is 90 degrees. In triangle 2, angle 4 is 90 degrees. So by AAS, because this is two angles and some other side, angle 1, angle 3, and some other side AB. Now, who can tell me which is the side included by angle 1 and angle 3? Which is the side included by angle 1 and angle 3?
AQ.
AQ. AQ. Very good, Bhavishya. Very good. AQ. And somebody else, not Bhavishya, tell me which is the angle, sorry, which is the side included by the angles 2 and 4?
Ma'am, AP.
A?
Ma'am.
AP.
Ma'am.
AP. Angle 1 and angle 3 include the side AQ. Angle 2 and angle 4 include the side AP. But we have not mentioned about these two sides. We have written AB is equal to AB. So that's why it is two angles in some other side. If supposing we had written AQ is equal to AP, if we had that information, I mean, okay, if we had that information, if we have written AQ is equal to AP, then it will be two angles and the included side. Then it will be ASA. But here it is AA and some other side. AAS. Two angles and some other side. AAS congruence criterion. The two triangles are congruent to each other. So that's the first part, to show that the triangles are congruent to each other. And then we'll have to show that BP equals BQ, or B is equidistant from the arms of angle A. B is equidistant from the arms of angle A. See, this is B. B is equidistant, meaning from the arms of angle A. That is, the distance BP is equal to the distance BQ. Yeah, that's true, because now the triangles are congruent. So CPCT, we have PB is equal to QB. CPCT, PB is equal to QB. The triangles we proved are congruent. So CPCT, we have PB equal to QB. This is PB, this is QB. CPCT. Yeah. Yeah, take a picture, children. All right. Children, use the emoji. Raise your hand. Swati, Bhavishya, Laksha, Prenu, Niveda, Mritsa, Ragamai, Anugraha, Haripranav, Srivatsan, Abhishekan, Sahana. All right. All right, children. Thank you so much for making it to the class. I had no other option. That's the reason why yesterday some of you had texted me that it was inconvenient to take up, so I couldn't go ahead with yesterday's class. All right. So one more hour, I'll compensate. So tomorrow we have the regular session. So tomorrow we'll decide if we can make another session like this in the evening. That will decide tomorrow in the class. All right. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.